Okay, for question part B, okay, given that W is equal to 1 plus I square root 3, and then they ask us to express W to the power of 5 in the form of R cis theta. So basically this is actually a polar form. Okay, so first step is you take the value of W. Okay, I will write here. So we have W equal to 1 plus with I square root 3. So basically it is square root 3I long. Okay, they ask us to express it in the form of R cis theta. So R cis theta is our polar form, right? Okay, so here find value of R and the theta. So to find the value of R, we have to use square root x square plus with y square. So by right, 1 is your x, square root 3 is your y. So you substitute inside, you're gonna get 1 square plus with square root 3 square. So total you will get here, when you calculate, you're gonna get equal to square root 4 and then equal to 2. Then you find theta, which is inverse tangent y divided by x. You're gonna get equal to inverse tangent, your y is square root 3 divided with 1. Then you're gonna get pi over 3. So from here you already got your theta and r. So your W, when you want to transform the complex number into polar form, you will get R cis theta, which is your W is equal to R is 2, cis theta is pi over 3. So settle for this part. But then the question, they said they want W to the power of 5. Okay, so W to the power of 5, basically you can use the formula Z to the power of n equal to Rn cis and theta. So we can apply to this as well, which is if you want to know W to the power of n, you can get R to the power of n cis and theta. So here your W to the power of 5 is equal to 2 to the power of 5 cis 5 multiplied with theta, which is pi over 3. So final answer here is equal to 2 to the power of 5 is 32 cis 5 theta 5 pi over 3. So this is your answer for this question. Okay, now we go through the second question, okay, where they said given that Z is 2 minus 2 square root 3i, express Z in the polar form given the principal argument. So by right, we just have to form a polar form from the complex number Z. Okay, so I write this in the next question. We have B. So question B, we have Z is equal to 2 minus 2 square root 3i. Okay, now we have to use polar form. So polar form is R cis theta. So the same step, find the value of R first, square root of x square plus y square. So x square, this is your x, this guy is your y. So 2 square plus with negative 2 square root 3 square. So you're gonna get, use calculator, your answer is 4. And then you find theta, which is inverse tangent, you y over x, you're gonna get inverse tangent negative 2 divided with 3 divided with 2. Then you're gonna get equal to negative pi over 3. So from here, you already got the answer. So form the polar form of the complex number. Z is equal to 4 cis negative pi over 3. So this is your answer for this question. Okay, settle for this one. Now we proceed to the next one, question C. Question C, they said, question number 2. They said using the De Moivre theorem, okay, find the all cube root of Z. Remember, cube roots. Cube roots mean our n is equal to 3. So now we proceed to this question. So since we want to use the De Moivre theorem, right? So by right, to find all of the cube roots, it is actually zk equal to z to the power of 1 over n equal to r to the power of 1 over n cis theta plus 2 pi k divide with n, where k is equal to 0, 1, 2 based on the number of cube root that we have. Okay, so since we want to find cube root, okay, our n is equal to 3. So you substitute inside. So your z1 over 3 is equal to r to the power of 1 over 3 cis theta plus 2 pi or k divide with 3, where k start with 0, 1 and 2 only because we have 3 roots. Okay, now to find zk, it is actually r to the power of 1 over 3. R we have equal to 4 already from the question that we got here. This guy, it is equal to 4. So 4, 1 over 3 cis theta we also have, which is equal to negative pi over 3. We put negative pi over 3 plus with 2 pi k divide with 3. Okay, now we have to find z0, z1 and z2. So z0 is equal to 4, 1 to the power of 1 over 3 cis negative pi over 3 plus with 2 pi, k is 0, divide with 3. Then here you're going to get 4, 1 to the power of 1 over 3 cis. You calculate negative pi over 9. Okay, then remember cis theta is equal to cos theta plus I sin theta. So we transform into this form. 1 over 3 cos negative pi over 9 plus with I sin negative pi over 9. Then what you have to do is just find the value. So 4 to the power of 1 over 3 multiply with cos negative pi over 9, you're going to get 1.4917, okay, minus with 4 to the power of 1 over 3 multiply with sine negative pi over 9, then you're going to get negative 0.5429i. So this is your z node. Okay, now you do for z1. So z1 is equal to 4 to the power of 1 over 3 cis negative pi over 3 plus with 2 pi, k we have 1. So you substitute 1 inside, divide with 3. Then here you're going to get 4, 1 over 3 cis, and then the angle inside will become 11 pi over 9. Then you separate, change cis into cos and sine form, which is cos 11 pi over 9. You will get, and then plus with I sine 11 pi over 9. So here you're going to get, you expand 4 to the power of 1 over 3 multiply with cos 11 pi over 9, you will get negative 1.216 minus with, okay, you multiply 4 to the power of 1 over 3 with sine 11 pi over 9, you will get 1.020i. So this is the z1, the second root, like this. Okay, so the next one, I think I have to continue at the next page. So which we have z2. Z2 is equal to 4 to the power of 1 over 2 cis negative pi over 3 plus with 2 pi, k is 2, so multiply with 2, divide with 3. Then you calculate the one that is inside this bracket. So you're going to get here 4 1 over 3, sorry, 1 to the power of 1 over 3 cis 5 pi over 9. Okay, then you will get 4 1 over 3. Here you change it to cos plus I sine form. Okay, I sine 5 pi over 9. Okay, here you will get equal to, okay, convert, find the value 4 to the power of 1 over 3 multiply with cos 5 pi over 9, you will get negative 0.2756 plus with 4 to the power of 1 over 3 multiply with sine 5 pi over 9, you will get 1.5632i. So you have z2, the last root is equal to this one. Okay, now you settle for all of the roots. Then the last question, they say illustrate all the roots on Argand diagram and state the angle between successive roots. So this one, you draw Argand diagram, and then basically from each of the roots, okay, you actually can get each of the point, okay. From z node, you have 1.4 and negative 0.5429. So basically it could be around here long, 1.4, maybe here. So this is 1.4, and then negative 0.5 should be negative 0.5, maybe around here. So your graph will be like this. Oh, sorry, a straight line, yeah. Okay, this is your z node. The next one, we have z1 equal to negative 2.7 and 1.5. So negative 2.7, maybe around here, negative 0.27, 1.56, maybe here is 1.56. Then this is your point. Oh, sorry, you use a straight line, huh? Okay, the next one you have is negative 1. Oh, did I make a mistake? Oh yeah, the value is wrong here. And this one I actually swapped, yeah. Oh, sorry, yeah. This one should be 2. This one should be, yeah, 2, 2, 2. So this is the answer for Z2. Okay, sorry, yeah. Okay, another one, the one that I make a mistake here. This one should be 1 instead of 2. Okay, so this is the answer. And then here you have, which is negative, the last one, negative 1.2. Okay, which is maybe around here is negative 1.2. Okay, and then the imaginary is, sorry, this one is not y, it should be imaginary. This one is real. Argand diagram, okay. And then our imaginary is negative 1.0, maybe around here, negative 1.0. So this is your point. Draw a straight line. Now you got already like this. Then by right, if you check, right, because we have 3 successive rows, this one, and also this one. So how to find each of this? So remember, 1 full rotation is equal to 2 pi. Okay, so angle between the roots is 2 pi divided with 3. Why? Because we have 3 roots right now. So you're going to get the answer is equal to 2 pi over 3 for each of the roots. So 2 pi over 3, this one 2 pi over 3, this one 2 pi over 3. Then you're done for this question. Okay.